Guys, I want to joke first, so stay tuned. Bye.
Hi and Assalamualaikum. My name is Muhammad Nur Syahir bin Muhammad Nur Azam. My metric number is 1202561. So today I want to present to you guys about the introduction of logarithm. So let's go. Logarithm is the inverse function to exponentiation. So the logarithm of a given number x is the exponent to which another fixed number. The base a must be raised to produce that number x. So the general equation is log ax equal to y, which means multiply a by itself y times to get x. In other words, x equal to a the power of y. A is the base of logarithm. So I think that's all from me. I hope you guys understand about the logarithm. So let's proceed to the next presenter. Thank you.
My name is Ahmad Faiq bin Sayuti. My metric number is 1202970. Today I will present to you about explanation of logarithms. So let's go.
For example, log base 2 8 is equal to 3. So 2 need to multiply by itself 3 times to get 8. So 2 times 2 times 2 is equal to 8. Logarithms are useful for expressing quantities that span several orders of magnitude. For example, chemistry, the pH equation. pH is equal negative log 10. Concentration H plus has small change in pH results in a large change in concentration H plus. Other example is Lenz's equation.
So guys, what's your opinion about logarithms? Are you guys still there? So I think that's all for me. So let's move to the next presenter. Thank you.
Hi guys. Okay, before that, okay guys, you already know what is logarithm and what is the concept of logarithm. So let's check it out. What is the significance of logarithm in chemistry?
Significance of logarithms in chemistry problem. It's just a helpful way of compressing an extremely wide number scale into something more manageable. The log of a number to a particular base is the power that base must be raised to equal that number. So, the log to the base 10 of 100 is 2, because 10 to the power of 2 is equal 100. So, we can say that by using logarithm, it can compressing an extremely wide number scale into something more manageable. Okay? Acidity depends on the concentration of hydrogen ions in aqueous solution. The range is very wide, so we can have a descending scale of concentration of hydrogen like this: 1, 10 to the power of -1, 10 to the power of -2, 10 to the power of -3, and 10 to the power of -4. If we take the log to the base of 10 of these numbers and stick a minus sign in front, we get 1, 2, 3, and 4. This gives us our familiar pH scale. So a solution of pH 3 is 10 times more acidic than a solution of pH 4. Guys, have you heard this story? It's so funny. In the UK, we had a company that was pumping acidic effluent into the water supply. Their dad said, "You can rest assured, our company are making every effort to get that pH reading back down to 0. I guess he didn't know about logarithms. The same reasoning applies when we are comparing the relative strength of acids and bases. A weak acid may have a Ka value of 10 to the power of -5, which would give a pKa values of 5. The lower this value, the stronger the acid. Okay, by using logarithm, it also gives a quick way of calculating the pH of a weak acid. If you know its concentration and pKa. So if it gives quick way of calculating the pH, either it's a weak acid or a stronger acid, it's a weak base or stronger base. Okay. If you look at the equation below, you can see that log is also used in one of the most important in chemistry, as it dictates whether any change can occur at all. So let's show how important logarithms being used in chemistry problem. So that's all from me. We go to the next presenter.
Hi guys, my name is Fareez and I'm going to present you a few examples of questions. Okay, question 1. Given a solution of concentration of ion hydrogen equal to 4.5 times 10 to the power negative 5 molar, find pH, pOH and concentration of OH minus. Hence, state if the solution is acidic or basic. So the formula to find the pH is pH equal to negative log concentration of H plus. So just plug in the concentration of H plus that already given in the question. So we can get pH equal to 4.35. So we can find the pOH by formula pH plus pOH equal to 14. So pOH we can get 9.65. So from the formula of pOH equal to negative log OH minus concentration of OH minus, you can rearrange the equation to find the concentration of OH minus. So we plug in the pOH that we already calculate, and we can get the concentration of OH minus equal to 2.2 times 10 to the power of negative 10 molar. So pH is 4.35, so the solution is acidic. Question 2. Given 0.0025 molar of sodium hydroxide, find the pH and concentration of ion hydrogen. So this question gives us a strong base. So a strong base ionized completely. So the concentration of OH minus is the same as the concentration of NaOH. So we just move the point and then we can get the concentration of OH minus equals to 2.5 times 10 to the power negative 3 molar. So by using the equation pOH equal to negative log OH minus, we can get the pOH 2.6. Then we can find the pH, which is 14 minus 2.6, and we get 11.4. So like the question 1, we can rearrange the equation pH equal to negative log concentration of H plus, and we can get the concentration of H plus. Just plug in into the equation and we can get the concentration of H plus 3.98 times 10 power negative 12 molar. Okay, question 3. It is a bit tricky because it is a buffer question. So a buffer solution is prepared by dissolving 0.12 mole hydrogen monochloride and 0.095 mole of hydrogen in 250 ml of water. Calculate the pH of this buffer solution. So then we see a Kb. Kb is a basic dissociation constant of hydrogen equal to 1.7 times 10 power negative 6. So we can see that when there is a Kb, it shows us that the base is a weak base. So we can find the concentration of hydrogen monochloride and hydrogen by using the formula mole over volume. They already give us the mole and the volume. So we can just calculate the concentration of hydrogen monochloride is 0.48 molar and the concentration of hydrogen is 0.38 molar. So this equation is actually a Henderson-Chassabat equation. So we can just plug in the information that we already calculate. So pKb is equal to negative log Kb, which is Kb is already given in the equation. So just plug in and then just plug in the concentration of hydrogen monochloride and also hydrogen, and we can get the pOH equal to 5.9. But this is just a pOH. We need to find the pH. So pH equal to 14 minus pOH. So the pH equal to 8.1. So if we look at the page 6, we can see the derivation of Henderson-Chassabat equation. So this is the derivation of the equation that we just used in the question 3.
कभी कभी ब्रेक लो, किटकैट खाओ, न जाने अगला पल क्या ले आए। किटकैट ब्रेक बनता है।
Question 4. The product of concentrations of water is 1.0 times 10 to the power of negative 14. If a product has concentration of H plus is 4.3 times 10 to the power of negative 9, then find whether the solution is basic or acidic solution. So, for this question, we determine either the solution is basic or acidic solution. Okay, basically for this question we will have two answers. Okay, if you look at the solution, negative log multiply concentration H plus with concentration OH minus equal to negative log concentration of water. By using law of logarithms, we separate the log into negative log concentration of H plus negative log concentration of OH minus equal to negative in bracket negative 14. Okay, then we get concentration of H plus multiplied with concentration of OH minus over concentration of H plus equal to concentration of water over concentration of H plus. Then we substitute the value of concentration of H plus given in the equation, and then we got concentration of OH minus equal to 2.3 times 10 to the power of negative 6 molarity. Okay, for basic solution, we use basic equation of pH, which is negative log multiplied concentration of H plus. Then we substitute the value, we got 8.37, and we use basic equation for POH equal to negative log concentration of OH minus, and we substitute the value of OH, concentration of OH, and we got 5.64 for POH. So you can see that this solution is more to acid. Okay, we go to the next question. Okay, for question 5, if 3 grams of substance A composed for 56 minutes, the mass of unreached A remaining is found to be 0.375 grams. What is the half-life of this reaction if it follows first-order kinetics? Okay, if you look at the solution, the original equation for first-order kinetics is concentration final equal to concentration initial exponent E to the power of negative kT. Then we move the concentration initial to the other part, and then we change the exponential to ln. We got K equal to negative ln concentration final over concentration initial over T. Then we substitute the values given in the equation to the equation, and then we got K equal to 0.0578 minute negative 1. Okay, and then we use half-life equation for first order kinetics, which is T half equal to ln 2 over K. And then we substitute the value, we got around 12 minutes, more accurately 11.98961, or within around 12 minutes. Okay, thank you.
Okay guys, Alhamdulillah, we have finished our discussion. So that's all from us. So I hope you guys enjoy our video and you can apply logarithms well in chemistry problems. So thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh. Ciao.